Good morning, guys. I hope you're doing well. I took some of the questions that you had from the homework and I condensed it to two different questions. First, problem number 18, we're finding the nth roots. We're given the number 1 and we're finding the 7th roots. So the important thing to know is that 1 can be rewritten in rectangular form as 1 plus 0i. A will therefore be 1 and b will be 0. The next step is to rewrite it in polar form. First, we find the modulus, which is equal to the square root of a squared plus b squared. That'll equal 1. Then we find theta by either doing the cosine of theta is equal to a over r, or the sine of theta is equal to b over r. They should both give you the same answer. Okay? When we do that, we find that our theta is 0. So our final polar form for that will be 1 times the quantity of the cosine of 0 plus I the sine of 0. Finally, to use the nth root formula, we plug r, theta, and n into the nth root formula. Okay? So the nth root formula, the nth root of r times the quantity of the cosine of theta plus 2 pi k over n plus I times the sine of theta plus 2 pi k over n. When we do that, we'll eventually get 1 the cosine of 2 pi k over 7 plus I the sine of 2 pi k over 7. Now, there are 6 values of k. Remember, k will be all the numbers in a sequence up to n minus 1. Our n is 7. K starts at 0, so it'll be 1, 2, 3, 4, 5, and 6. Notice there are 7 different k's. The actual answer for this problem would be to go and plug k in each time. However, I will accept this answer in this form because there are 7 of them. Number 27 was the type of problem where they give you an algebraic expression and you solve it using our new root rules. So, as you can see, it's a 5-step problem. The first step is to solve for x. You guys should be pretty good at this already. We end up getting the third root of negative 27i. Okay, the second step is just the conceptual part. We need to realize that when we solve for x, we're left with a complex number and we're taking the third root of a complex number. In other words, we're taking the nth root of a complex number. So, in order to take the nth root of a complex number, first we need to rewrite negative 27i in polar form. We do this very much the same way as in problem 18. We realize that negative 27i is the exact same thing as 0 plus negative 27i. So therefore our a will be 0, our b will be negative 27. We use our modulus formula of r is equal to the square root of a squared plus b squared, and we find that our modulus r is 27. Next we find the sine of theta. I'm not finding the cosine here because the cosine will be 0 over 27, or the cosine of 0. Okay? So I'm doing sine here, which is b over r. We plug it in, we get negative 27 over 27. And we find that's negative 1. The sine inverse of negative 1 is negative pi over 2 because it has to fall within that range, that domain. Remember that when we do the sine inverse, we add the periodicity identity of 2 pi. Normally it would be n. I put beta to avoid confusion. So whenever we're working in polar coordinates, we want our theta to be positive. So we're going to use that periodicity identity to add 2 pi to negative pi over 2 and get 3 pi over 2. This works because the sine inverse of 3 pi over 2 is the exact same thing as the sine of negative pi over 2 due to the periodicity identity. So therefore, our final polar form is 27 times the quantity of the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. Now, we can take that polar form and plug r, theta, and n into the nth root formula. And remember, for n equals 3, k will be all the numbers in the sequence starting at 0 to n minus 1. So it'll be 0, 1, and 2. We write our nth root formula. I would always suggest writing the formula first. Then we plug in our numbers and simplify. We get 3 the cosine of 3 pi over 2 plus 2 pi k over 3 plus I times the quantity of the sine of 3 pi 2 over 2 pi k over 3. Okay? So, I actually want you to go ahead and solve for k for each of these. There's only 3. It won't take too long. What important thing to note is that the 2 pi is going to refer to the numerator on top. Okay? So, in our numerator, we have 3 pi over 2. 2 pi is equal to 4 pi over 2. So, every additional k, we're going to add 4 pi on top. Now, for the denominator, we're going to multiply both denominators, 2 times 3, and end up with a denominator of 6. So our first answer will be 3 pi over 6, which simplifies to pi over 2. We're going to add 4 pi to our next answer and end up with 7 pi over 6. And we're going to add 4 pi to our third answer and end up with 11 pi over 6. Okay? Now, Christian, you had asked me about the quiz question number 2. For that one, we are not finding the area. We're using the law of sine or cosine to solve the triangle. So find me all the angles and find me all of the side lengths. If you have additional questions, please contact me through, and we can set up a Zoom cloud meeting to work on it in person. You guys are doing excellent, fantastic job on your quiz, Ben. Please let me know if you have any more questions. I'll see you guys in the next video.